the new middle rotor segments. I'll modify the thumbnail to this live stream after I've uploaded it, well, after the stream's finished, to show you the new segments on the generator. Now I'm just going to start it. As I explained, we're making this smaller incremental steps, baby steps as you might call it, until we get this tweaked right. Now the middle rotor is underneath the canopy, obviously. Oh, maybe I should light on. A bit of stroke. So obviously there's nothing running right now because the oscilloscope is flatlined. So let's just turn the power on as it's starting by itself, because it doesn't have any cogging issues. Right, so we're using our reference LED as a basic load. It doesn't show up so well on the camera for some reason. I don't know why is that with it. I've got a slight balance issue because I haven't got it properly balanced. Needs balancing, and I was thinking about 3D printing another one actually, because I think I warped it a bit when I acetoned that one, and it's a little bit misshapen and it's causing me some balance problems. So we're accelerating. I've got an issue with it wobbling a bit. It's clicking somewhere. Hang on. It's annoying. That's catching on the canopy, that's what's clicking. Bloody thing. Anyway, I'll sort that out later. The LEDs are nice and bright, and I'm going through 2 chokes at the moment. Our speed is 1134 climbing. Now if you watch the previous live streams, you will know the difference between this test and the previous test. You'll be able to see from the RPM. Now obviously we're running 2 LEDs back to back on the AC waveform. Now what's most interesting, what's useful, is the fact that I was aiming in the new was then down and up like that. It was like a V shape, the waveform. It was distorted. Now we have definitely sorted that problem out, but we still have an issue. So this is what we have now. So the middle rotor is giving us a much closer to a sine wave. Now I know why this is. This distortion is caused by the fact that the outside rotor and the left side rotor and the right side rotors also need to be upgraded to the new rotor segments that I'm using in the middle. So that's the reason why we're having distortion in the waveform right now. That's why I've got this little notch here. It's because we have 3 rotor system, and there's slight overlap, staggering. So this is what we have for the voltage now. Peak to peak 12.6 volts. Psychic RMS is 3.12 volts. The frequency is about 60, jumping around, it's around 60 hertz. So right, and we're still picking up speed right now. And the LEDs, I've got them on high brightness right now because I'm actually using two chokes on here, so we're actually pushing a bit more power into the LEDs. I'm using it as just a reference right now, and we have much less drag when I actually short this out, but I can't really do that with one hand because I wanted to show you around a bit. Our RPM now is 1195. The input current, we're at 6 volts. The current is currently, it'll drop down to 195 milliamps. It will drop down to that once it picks up speed, but we're still dropping, and the voltage is still at 6.5 volts. So the top incrementations, every 2 is 1 volt. So 5, 6, 7. So because it goes a bit unstable, and you see what I mean? It's jumping around a bit. It'll settle. There we go. Right. Settle down in a minute. Current should be around 195 milliamps when it settles. It's because the internal resistor is a slight instability on the internal resistor. The current resistor is warming up. So 195, but it's still picking up speed. So I'll probably go 200 until it speeds up properly. But our speed is 1198. I've seen it up to 1200 actually. 1200, and that's 1230. I've seen it up there without any LEDs on, without any load on at all. But as I say, I've got 2 chokes powering the LEDs right now. Now what is interesting is the fact that this is actually running faster now with a new middle rotor than it was before. In there somewhere, that's affecting speed as well. It's caused it to drag a bit. So I just wanted to show you that it's definitely an improvement. What I need to do is print more segments for the outside, the rotor on this side and the rotor on the back. I need to do them, redo them with the new rotor, the new segment design, so that it's all equal. Because the new ones, they actually do negate that drag by pushing forwards instead of dragging backwards, if you know what I mean. It actually accelerates when it's more. It doesn't accelerate to the point where it's over unity. We don't have that. What we simply have is a situation where a lot of the drag that normally is right. Get So imagine you're riding a bicycle. I'll try and use an analogy. Imagine you're riding a bicycle, right? It's like you've got somebody else on a tandem behind you also riding the bicycle, right? The other person is taking away some of that effort that is required to pedal the bicycle, right? Well, that second person is the anti-drag system on this generator, right? So that it's like an invisible person that's pedaling as well to move it forwards. So, but they're not going to drive it entirely without you being there. You still need to be there pedaling, right? So we're still going to make this thing spin, but it's less. It's less work. It's easier to pedal, right? You get what I'm saying? So I'm just trying to use an analogy to explain it simply, so that people that don't understand electronics or technical things can get an idea what I'm trying to do with it. So what I do is by using an anti-drag magnet array, like similar to this, like I was doing previously on the magnet motor I was experimenting with. When we have an equal opposite reaction pushing against it, instead of it dragging backwards, it's pushing it forwards. So it cancelled out some of that braking effect, and it's only energized while the coil is energized. And once the coil gets to the end of the array, before it gets to the end of the array, which would cause it to cog, the field in the coil collapses. And when that field collapses, it doesn't cog, right? You see what I'm saying? So I'll update the thumbnail with a new photo I took yesterday of the rotor with all the segments put in. I'm definitely happy with it. So this is why I wanted to do it just on the middle rotor right now. I wanted to first determine if it's going to be a positive gain or a negative, right? Because I didn't want to print all of these, I'm trying to say plastic, I don't want to print or load another 18 segments with the magnet arrays if the middle rotor isn't going to be a benefit. So that's why I wanted to do just the middle rotor, just one rotor for now, to compare it with the previous tests I did. And now I've come to the conclusion it definitely is an improvement. So what I'm going to do is print another 6 segments for one of the rotors, probably the one at the back, the one that goes anti-clockwise, looking at it from the back. So then I'll do that side, and then we'll take more readings on RPM, input current and waveform. So once I've determined that it is definitely going in the right direction, then I'll do the third rotor. So I'm just going to do baby steps right now, because I don't want to spend all my money on plastic because trust me, I'm getting a lot of it. I mean, all the previous segments are in this bag. And I've got quite an accumulation of segments now, as you can see. Yeah, so I don't want to keep printing stuff just for the sake of it. I want to make sure I'm on a positive track and not going down the wrong alleyway, if you know what I mean. And so the power supply is currently running. The power supply that's driving the motor is currently running on the uninterruptible power supply, which is stable, so it's giving a stable output voltage. That's the MGE, so I'm running on that. Our current now is a fraction at 200 milliamps, so that's going into 6 volts for the motor which is driving it, right? So we're definitely improving on that. So if you remember it, when I first, well, I'm not saying when I first, but when I did these tests, so I think it was around November, December time last year, I was having to run this thing at about 12 volts. I was running this on a 9.1 volt battery. So we were running this thing at about 9.1 volts, and we were probably about the same RPM. So we have definitely made some improvements, because the fact that I'm only running this at 6 volts now instead of 12 or 11.1 volts shows that we are making some headway. So anyway, doing a video of the oscilloscope, and sorry about my hand, I can't keep it still. It's very stable actually. Now what I need to do really is bypass the LEDs and show you what happens when I short them out. So if I overload the LEDs, and it could pop them, they actually turn a bit orangey coloured, and that could blow them. But let's just see, a bit orangey. Now we're basically full load into the LED instead of going through the chokes, and you'll see the RPM is dropping now, look. But it's not dropping like a stone. It's not dropping too much. I've seen it drop to around 950 RPM. I've done this. I don't want to blow the LEDs, so I'm going to take that off, because I am probably sending 60 milliamps into those 2 LEDs right now, and that's not a good idea. It could short out. So anyway, I thought you'd find that interesting. We are definitely getting somewhere. Now if I take one of the chokes out of line, that one, right, take one choke out of line, so we're running them through one choke now, which a previous test, let's see what it climbs up to. I need some coffee actually. Where's my coffee gone? So the choke's in series with the AC output, as I say, that blooming sellotape or something's catching in there. You can hear it clicking. I need to take the canopies off and look for where the sellotape's come off the drum and cut it off or push it down or something. So we've just got the LEDs running through. Oscilloscope says sorry, I've got a sandwich a bit ago and that's why I'm keep burping. Oh dear. Let's see what the input current is while we're at it. Input current, it's fraction under 200 milliamp. It looks like 197 milliamps. I think it's settled there. Oh, it's still climbing a bit. Yeah, I think it's peaked about there with this one LED on, with one choke through the LEDs. Anyway, thought you'd find that interesting. So I'm just, as I say, baby steps right now. I'm going to print another 6 segments for the magnet array on the back, and then I can get that one populated as well. So when I disconnect the power to the motor, I'm going to turn it off now. We'll see how long it takes to spin down. So I've disconnected the clip. I'm going to take the belt off. Right, are you watching? Oop. There we go. I've taken the belt off. We're just freewheeling. LEDs. So we are literally just freewheeling now. Trying to get the LEDs in as well. The light doesn't help, does it? I need to turn the light out now. Actually, I'll do that. As I say, there is no cogging with this. When I take the belt off, you can see that clearly when it comes to a stop, and it takes a while to do that. It takes forever sometimes. But we're nearly there. My sun's gone in now. We can almost see the AC cycling now on the LEDs. Because one LED takes a positive cycle, the other LED shows a negative cycle. They're about to extinguish themselves now. We're on the point where they'll no longer be lit. So I've been chilling out watching some snooker a little bit. I'm going to start printing 2 more segments each day for the other side. The reason I'm doing two a day, not all of them at once, is because it's just a lot. I don't want to rush because I've got to acetone treat each pair, and when you start putting more than 2 in my acetone chamber, they can get stuck together. So I'll just do 2 a day, and then as the cycle I take the 2 out the following day, print another 2, and so on. So you can see as there is no cogging on this thing, otherwise it would have stopped long ago. I mean, that's because there's nothing to cog against, because we're using the actual magnet, the actual drum magnets on the drum on the rotor. It acts as a stator, a moving stator. RPM is currently 166. You can see how fast it's dropping. Basically, it's dropping 1 RPM per second. At the slower speeds, there's less air resistance. And that's the main drag force, really, when you're at higher speed, is the air resistance. The faster this thing goes, the more external drag you get from the air itself, the wind, because it's sucking air in like a vacuum cleaner and it's pushing it out somewhere. So that, in effect, is what slows it down mostly at higher speeds. So this is why I want to stick with lower speeds if I can. I really don't want to use this at higher speeds, because you lose efficiency because of the drag problem, wind resistance. You end up turning the damn thing into a vacuum cleaner or electric fan, you know what I mean. What are we at now? About 78 RPM, 76, 75. So I just thought I'd show you it coming to a stop, because I don't think I've done that. Don't think I've done it recently anyway. Quite obvious there's no cogging. There is a slight imbalance though I need to sort out with the weight distribution around the rotor. That's why I was saying I might actually print another rotor for this thing. So yeah, there's a slight weight problem. That's why it just went backwards there. I need to sort that weight problem out. It's the rotor that's on the front that's not balanced. I balanced the other two that are at the back. I balanced the middle rotor and the rotor at the back, but I didn't balance this pink one at the front because it's slightly distorted. So I'm going to print a new one, I think, because it's just easier than it is to try to fix the one that's got a bit of a kink in it. Anyway, thank you for watching, and we'll see you later, alligator.